Hi everyone. In the M4 hackathon, I first chose to build a feature engineering. In this feature engineering process, I created several new features from the original contact data to enhance predictive modeling. I generated binary indicators such as never contacted for clients never reached before and first contact for clients with no previous contacts. I adjusted p days to replace -1 with 0 to represent no previous contact numerically. I also calculated total contact as the sum of current and previous contacts and define high campaign to flag clients contacted three or more times in the current campaign. These engineered features capture both the history and intensity of client interactions, providing more informative inputs for modeling. To adjust the class imbalance in the training data, I calculated the scale pulse weight as the ratio of negative samples to positive samples. This way helps the model give more importance to the minority class during training, improving its ability to correctly predict rare events. By passing scale pulse weight into the model, I ensure that the learning algorithm accounts for imbalance and reduce bias towards the majority class. When splitting the data into training and validation sets, I use the stratified split by setting stratify equals y. This ensures that the proportion of classes in both sets matches the original data set, which is especially important for imbalanced data. To doing this, I make sure that the model sees a representative distribution of both classes during training and evaluation. In the model, I apply one-hot encoding to the categorical columns to convert them into a format suitable for machine learning. I then build a baseline model, which achieves a AUC of about 0.78 on the validation set. To further improve performance, I use randomized search CV to search for the optimal hyperparameter combinations. After evaluating 40 different parameter sets with five-fold cross validation and ROC AUC scoring, the best model achieved an improved AUC of about zero point 0.8 on the validation set. This suggesting that hyperparameter tuning enhances the model's predictive performance. Then I draw a learning curve. My learning curve indicated a risk of overfitting at the beginning, as the training performance was significantly higher than the validation performance. To adjust this, I reduced the math steps and the number of N estimates and added L1 and L2 regularization. These adjustments help retrain the model in a more robust way, aiming to improve generalization and reduce overfitting. So by the end, my new learning curve is like this. It reduced the risk of overfitting, and it also fits the models well. To further improve predictive performance, I leverage AutoGluon, an ultimate machine learning framework, to automatically select and ensemble models. AutoGluon evaluates multiple model types, tunes hyperparameters, and combines them to maximize performance without extensive manual intervention. Using AutoGluon, the final model achieved an even higher AUC on the validation set, demonstrating that ultimate model selection and ensembling can effectively enhance predictive accuracy.